Hello, students. We are now in a new topic, and we will be talking about rational functions. But before that, we will have a review first about what are rational numbers. Okay, rational number in arithmetic, a number that can be represented as the quotient p over q of two integers such that q is not equal to 0. In addition to all the fractions, the set of rational numbers includes all the integers, each of which can be written as a quotient with the integer as the numerator and 1 as the denominator. In other words, if a number can be expressed as a fraction where both the numerator and the denominator are integers, the number is a rational number. In short, rational numbers are numbers that can be expressed as a fraction. These are the examples of rational numbers. So the two classifications of real numbers are rational numbers and irrational numbers. Examples of rational numbers are 5 over 6, 1.5, 3.78, 6 over 9, 8 over 3, square root of 4, negative 3, 0, negative 8 over 2, 36, 12, 9 over 3, 3, 70, 21. Or those numbers that can be expressed as fractions like the repeating, non-terminating decimals, and the irrational numbers are those numbers that can be expressed as fractions like square root of 5, negative square root of 2, the pi. Do you know what is the value of pi? That is 3.1416, the negative square root of 6, or in short, those numbers that cannot be expressed as fraction, like the non-repeating, non-terminating decimals. Those are examples of rational numbers. And now we will go to rational expression. What are rational expressions? Rational expressions are called algebraic fractions. If we will say fraction, there is a denominator and there is a numerator. A rational expression can be written in the form a over b, where a and b are polynomials and b should not be equal to 0. Why is it that b should not be equal to 0? Or the denominator should not be equal to 0? Because it will be undefined. Okay, examples of rational expressions. That is 3 over x, 2x plus 9 over 10, 2xy squared over 5xyz cubed, x squared plus 9 over x squared minus x minus 6. So these are examples of rational expressions. Combination of numbers and letters. Now, if we are going to simplify rational expressions, we have some rules to follow. First, the rules in simplifying rational expressions. Number 1, factor the numerator and denominator. Number 2, write the product of the rational expressions. One factor containing the greatest common factor, or the GCF, of the numerator and denominator, and the other containing the remaining factors. Number 3, rewrite the factor containing the GCF as 1. And number 4, multiply the remaining factors by 1. So those are the rules in simplifying rational expressions. Next will be the rules in multiplying rational expressions. Number 1, multiply the numerators and denominators. Number 2, write the resulting numerator and denominator in factored form. Number 3, divide out any numerator with matching denominator factor. And number 4, simplify if possible. The next rule will be the rules in adding or subtracting rational expressions with like denominators. Number 1, you have to add or subtract the numerators. Number 2, retain the common denominator. Number 3, simplify the result. So this is just a review of adding and subtracting fractions. They have the same rules. Next will be adding, subtracting rational expressions with different denominators. Number 1, find the least common denominator or the LCD. What is LCD? It is a number that is divisible by the common denominators. Number 2, write the equivalent expression at each rational expression. Number 3, add or subtract the numerators and keep the LCD. And number 4, simplify the result if possible. And we will have also rules in finding the LCD or the least common denominator. Number 1, you list the different denominators that appear in the rational expression. Number 2, factor each denominator completely. And number 3, find the product of each factor with the greatest number of appearances with the denominator factorizations, that is, with the highest power. So you have to take note of those rules in simplifying rational expressions. Now we will go to rational equation. What is that? Rational equation is an equation that contains one or more rational expressions. So there are one or more rational expressions, and that is rational equation. Now there are 3 steps to follow in solving rational equations. Number 1, eliminate the rational expressions in the equation by multiplying both sides of the equation by the LCD or the least common denominator. Number 2, solve the equation. Number 3, you check your solution. It's really necessary to check your solution so that you can prove that the solution of your equation is correct. Okay, example 1, we have to solve for x. In dealing with variables, like why is it, well, we are always talking about x, y, or the other letters. You have to remember always, students, that variables are unknown numbers, meaning those pangitaon nga value of that numbers. So the given here in example number 1, we have x over 5 plus 1/4 equals x over 2. Our aim here is to find what number is that we are going to substitute the letter x there in the given equation. So there are 3 rational expressions here, and there are expressions at the left and the right side of the equation. Now, since the denominators are different, we have 5, 4, 2, so we will apply the rules of adding rational expressions with different denominators. And we need to find the LCD or the least common denominators. Now the denominators here are 5, 4, and 2. And we need to find what is the LCD of this. We have 20 because 20 is the least number that is divisible by 5, 4, and 2. And we will solve the equation now. The first step we're going to do is multiply both sides by the LCD 20. So we need to multiply the left side of the equation and the right side of the equation by 20. So we have 20 times x over 5 is equal to 4 over x. And 20 times 1/4 is 5. And 20 times x over 2 is 10x. And we apply the distributive property. And then we will simplify. Since there is 4x at the left and 10x at the right side of the equation, so we need to apply the subtraction property of equality. So we need to subtract 4x from both sides. So we have 4x minus 4x is 0. So the remaining number at the left is 5. And 10x minus 4x is 6x. And then to find the value of x, to find the unknown number that we will be replaced at the place of x there at the given equation. So we need to divide both sides by 6. Why 6? Because 6 is the number together with the variable x. So we need to divide 5 divided by 6 and 6x divided by 6. So the value of x is 5 over 6. And the last step is check. So you need to check if the solution that you have got is correct. So we have here 5 over 6 over 5 plus 1/4 equals 5 over 6 over 2. Since at the numerators are the places of x, so we need to substitute also the solution we have got. And we need to solve if that is true. So we have 5x over 5, and that is division of fraction. Now what shall you do if you have division of fraction? What's the rule? Do you remember? Okay. So you need to find the reciprocal of the divisor. And here, the divisor is 5. And we need to get the reciprocal, meaning the value of that 5. And what is the denominator of a whole number? It is 1. So the reciprocal of 5 over 1 is 1 over 5. That is why 5 over 6 times 1 over 5 plus 1/4 equals 5 over 6 times the reciprocal of 2. We have 1 over 2 or 1/2. And we have to follow the MDOS for multiplication, division, addition, and subtraction. So we need to solve first those multiplication. So we have here 5 over 6 times 1/5. We have to multiply both numerators and denominators because that's the rule in multiplication of fraction. 5 times 1 and 6 times 5. But to be easy is to apply cancellation so that we'll arrive at the lowest term. So we have 5 at the numerator here, we have also 5 at the denominator. We can cancel it out and we multiply the remaining. So 1 times 1 is 1 and 6 times 1 is 6 plus 1/4 equals 5 times 1 is 5 and 6 times 2 is 12. And we have to remember that 1/6 and 1/4 are unlike fractions, and if unlike fractions, we have to get the LCD first. So the least common denominator of 6 and 4 is 12. So we have to simplify. 12 divided by 6 is 2 times 1 is 2, and 12 divided by 4 is 3 times 1 is 3 equals 5 over 12. And 2 plus 3 is 5 over 12 is equal to 5 over 12. And now the left and right side of the equation are now equal, and it's true. So 5 over 6 is the solution. So therefore, our solution is correct. And we have a note here. An extraneous solution is an apparent solution that does not solve its equation. If in checking, the final answer is not true, so that's an extraneous solution. Kanang dili mag-equal ang left and right of the equation. Okay, next, we will go to example number 2. So we have here 1/4 equals 3 over x minus 1/2. Now we need to find the LCD of the denominators. So the denominators are 4x and 2. What have you noticed with the denominators? Okay, this combination of numbers and letters. There's 4x and 2. So we need to find the LCD of 4 and 2, and that is 4. And we need to combine also the variable x. So the LCD of the denominator is 4x. And what shall we do with 4x? We have to multiply both sides by the LCD 4x. So we have 4x times 1/4 is 1x or x. And 4x times 3 over x, we have 12. And 4x times 1/2, and that's negative 2x. We apply the distributive property, and then we will simplify. So we have to combine like terms now. So we have, we will add 2x to both sides. So 2x plus x is 3x, and negative 2x plus 2x is 0. So at the left side is already 3x, and the right side is already 12. Now we will divide both sides by 3 so that we can find the unknown number. Since 3 is together with x, so we need to divide both sides by 3. So 3x divided by 3 is x, and 12 divided by 3 is 4. Therefore, the solution of that equation is 4. And we will check. We have 1/4 equals 3/4 minus 1/2. So we have 1/4 is equal to 3/4 minus 2/4. And why it becomes 2/4 now? Because 3/4 and 1/2 are different fractions, so we need to find the LCD of 4 and 2, and the LCD is 4. So 4 divided by 4 is 1 times 3, and that is 3. And 4 divided by 2 is 2 times 1 is 2. Actually, 1/2 and 2/4 are equivalent fractions. They're the same. 1/2 is just the lowest term of 2/4. And now, we have 1/4 at the left side of the equation, and we have 3/4 minus 2/4, that is 1/4. And they are equal now. So, it's true, and that's 4 is the solution of the equation. We'll proceed to example number 3. So we have solve for x plus 1 over x plus 1 minus 3 is equal to 12 over x squared minus 1. So what have you noticed now with the denominators? And they are algebraic expressions. Now we need to find the LCD of x plus 1 and x squared minus 1. Why is it that the LCD is x plus 1 times x minus 1? Because if we are going to factor x squared minus 1, the factors of that algebraic expression, that is the difference of two squares. So we have x plus 1 and x minus 1. And we have also x plus 1 at the left side of the equation. So we can use that as the LCD. And we need to write the denominator in factored form. So we have here, for x plus 1 over x plus 1 minus 3 is equal to 12 over x plus 1 times x minus 1. So we write the denominator in factored form. And then we multiply both sides by the LCD. Again, our LCD is x plus 1 and x minus 1. So, we have here why it becomes 4x plus 1 now. Because the denominator of 4x plus 1 is x plus 1. And we will cancel out to be easy. We will apply cancellation. We will cancel out the x plus 1 here. And the remaining factors for the LCD is already x minus 1. So we multiply for x plus 1 times x minus 1. And then, since we will distribute this, so we need to multiply also negative 3 times x plus 1 times x minus 1, because negative 3 here is a whole number, and then the denominator is considered as 1. So at the right side of the equation also, we have 12 over x plus 1 times x minus 1 times the LCD. And we can cancel out this because they have the same. We have in the numerator and the denominator, they are the same, so we can cancel them. So we have 12 already here, the remaining at the right side of the equation. And here at the left side, we have lots of remaining algebraic expressions. We need to simplify them. And we'll apply the FOIL method. So we have 4x times x, that is 4x squared. And then 4x times negative 1 is negative 4x. 1 times x is 1x or x. And we need to combine them. So negative 4x plus x, that is negative 3x. And positive 1 times negative 1 is negative 1. And here, we know already that x plus 1 times x minus 1 is equal to x squared minus 1. So we will multiply 3, that is negative 3 times x squared minus 1. So we have negative 3x squared plus 3, because negative 3 times negative 1 is positive 3 equals 12. And when it comes x squared minus 3x minus 10 equals 0, because we combine like terms. We have like terms here again. Like terms are those terms with the same variables and the same exponent. So we have here for x squared minus 3x squared is 1x squared. And then minus 3x, and negative 1 plus 3 is positive 2. And there is 12 here at the right side. So we need to subtract 2 both sides of the equation. So we have x squared minus 3x is equal to 10. And then we will subtract again and both sides of the equation. So we have x squared minus 3x minus 10, and 10 minus 10 is 0. And what shall we do with this binomial here? We will factor this so that we can have the solutions. So we have the factor of x squared, or x and x, and the factor of negative 10 is negative 5 and 2. So our factors here are x minus 5 and x plus 2 is equal to 0. And we need to find the solutions. We have x minus 5 equals 0, or x plus 2 equals 0. And we need to add both sides of the equation here, the first factor. So x minus 5 plus 5 is 0. So x is the remaining at the left side, and 0 plus 5 is 5. Here at the other factor is x plus 2 equals 0, and we need to subtract 2 both sides. So x plus 2 minus 2 is x, and 0 minus 2 is negative 2. So the solutions are 5 and negative 2, and those are the values of x there. We're going to check our equation. We have here a real number that is a real life situation, and this is a word problem. We have find two consecutive integers such that the sum of 1/3 of the first and 1/4 of the second is 9. So what shall we do if it is a word problem? What have you noticed? There are two consecutive integers, and their sum is 9. The sum of 1/3 of the first and 1/4 of the second is 9. So to solve, we have let n be the first integer and n plus 1 is the second integer. And we need to make an equation for that problem. So we have to translate the given word problem into symbols. So we have here 1/3 of the first integer. So what shall we do with that? How we will translate that into mathematical expression? So 1/3 times n, because we let n as the first integer. And then we know already the plus, and 1/4 of the second integer is 9. So we need to write 1/4 of the second integer and we assign n plus 1 as the second integer. So we have 1/4 times n plus 1, and is in mathematics can be translated as equals. So equals 9. So we have now our equation 1/3 n plus 1/4 times n plus 1 is equal to 9. So as we notice that 1/3 and 1/4 are different fractions. We need to find the LCD. Again, what's LCD? The least common denominator. So the LCD of 3 and 4 is 12. This is the least number that is divisible by 3 and 4. And we will multiply both sides by the LCD 12. So we have now 12 times 1/3 n plus 1/4 times n plus 1 is equal to 12 times 9. Remember, whatever number we're going to multiply at the left side of the equation is the same number that we're going to multiply at the right side of the equation. That's the multiplication property of equality. Okay, now we will apply the distributive property. So we have here 12 times 1/3 n. Why it becomes 4n? Because 12 times 1/3 is 4 times n, that is 4n. Here we have 1/4 n and plus 1/4. So we have 12 times 1/4 is 3 times n is 3n. And 12 times 1/4 is 3. And at the right side of the equation, we have 12 times 9, that is 108. That is why we need to apply the distributive property so that we can combine like terms and we can simplify. So we have like terms here. We have 4n and 3n. So we need to add. We have 7n plus 3 equals 108. And we will subtract 3 from both sides. So we have here 7n is equal to 105 because 7n plus 3 minus 3 is 0, and 108 minus 108 minus 3 is 105. And why we got 15? Because we divide both sides by 7. So we have here, since 7 is together with n, so we need to divide both sides of the equation by 7. 7n divided by 7 is n, and 105 divided by 7 is 15. So our first integer is 15 because we have let n be the first integer. So we have 15. And now we will find the second integer. As we know a while ago that the second integer is n plus 1. So we have already the first, that is 15, plus 1 is 16. And that's the second integer. And the consecutive integers, the two consecutive integers are 15 and 16. What do you mean by consecutive? That is pasunod, consecutive. So 15 and 16 are the missing numbers there in the given problem. Okay, we have also motion problem here. An express train travels 150 kilometers in the same time that the freight train travels 100 kilometers. If the express train goes 20 kilometers per hour faster than the freight train, find the rate of each train. So there is an express train and a freight train. So we have to find the rate of each train. So we have let R be the rate of the freight train and R plus 20 the rate of the express train. Why the rate of the express train is R plus 20? Because here, the problem, we have if the express train goes 20 kilometers per hour faster than a freight train, meaning mas paspas siya mudagan 20 kilometers kaysa freight train. So mauna, if R is the rate of the freight train, so we need to add 20 as the rate of the express train. And we first construct a table so that it will be easy for us to understand. We have the distance, the rate, and the time. So we have a freight train, the distance is 100, the express train is 150, and the rate of the freight train is R, and the rate of the express train is R plus 20. And we have the time, we have 100 over the freight, and that is for the freight train. And for the express train, we have 150 over R plus 20. Why we got this formula? Did you remember what is the formula for distance equals rate over time? Okay, now we have the equation of the fact that travel is the same leads to the equation 100 over R is equal to 150 over R plus 20. So those are the equations now. And we have to take note that the equation is a proportion. Okay, look at this. We can apply proportion for this equation. And we can apply cross multiplication. So we have 100 times r plus 20 is equal to 150 times r. So we apply the cross multiplication to solve for r. And we need to apply the distributive property here on the side of the equation. So 100 times r is 100r, and 100 times 20 is 2,000. And 150 times r is 150r. And to solve for r, we need to simplify. We need to combine like terms here. So we have here 100r minus 150r is negative 50r. And we need to subtract 2,000 both sides also. So we have 100r. Again, 100r minus 150r is negative 50r, and 150r minus 150 is 150r is 0. So at the right side is already 0 now. And we have still negative 50r plus 2,000 equals 0. So that we can get the r, which is the rate. We need to subtract both sides by 2,000. So negative 50r plus 2,000 minus 2,000. So we have negative 50r at the left side of the equation. And 0 minus 2,000 is negative 2,000. And we still have negative 50r is equal to negative 2,000. Since the constant number together with the r is negative 50, so we need to divide negative 50 both sides. So negative 50r divided by negative 50 is r, and negative 2,000 divided by negative 50 is positive 40. And that's the rate of the freight train. And as we know, the rate of the express train is more than 20. So rate sa freight train, we have now here r plus 20, and our r here is 40, and that's the freight train's rate, plus 20 is 60, and that's the rate of the express trains. Therefore, the freight train's rate is 40 kilometers per hour, and the express train's rate is 60 kilometers per hour. Okay, next we will go to rational inequality. What do you mean by the word inequality? Okay, from this word, that means not equal. So rational inequality is composed of rational expressions combined with less than or equal, greater than or equal, less than or greater than sign. So those are the indication of inequality, meaning not equal. We can see some symbols like this. It represents inequality. So some examples of rational inequalities are 1 over x is less than or equal to 7. X plus 2 over x minus 3 is less than or equal to 0. 1 half plus 2 over x squared minus 1 is greater than 1. And 5 all over x squared minus 4x minus 5 is greater than or equal to 0. So those are examples of rational inequalities. We have to take note of those different symbols. If rational equality or rational equation, one symbol only, that one symbol only, and that is equals. And here, in rational inequality, we have 4 symbols that we need to remember. That is the less than or equal, the greater than or equal, and less than and greater than signs. Now, what are rational function? Rational function can be written in the form f of x is equal to n of x all over g of x, where n of x and g of x are polynomials and g of x is not the zero polynomial. And the domain of a rational function f of x is equal to n of x over g of x is all the values of x that will not make g of x equal. So we can have the following definitions here. We have polynomial function. The function defined by f of x is equal to a sub n, x to the power of n plus a sub n minus 1, x to the power of n minus 1 plus a sub n minus 2, x to the power of n minus 2, and so on. We have a sub 1 times x plus a sub 0, where a sub 0, a sub 1, and a sub n minus 1, and a sub n are real numbers. And a sub n should not be equal to 0, and n is a non-negative integer. So those are polynomial functions. And we have three kinds of polynomial functions here. The constant function. The constant function is the linear function f in f of x is equal to mx plus b, where m is equal to 0 and b are any real number. So that's a constant function. The slope is equal to 0, like f of x equals 10. Okay, that is a constant function. There is no slope, only y-intercept, and that's any real number. But that's an example of constant function. F of x equals 1000, f of x equals 1, f of x equals negative 5. Those are constant functions. Next is linear function. Linear function is linear function f in f of x equals mx plus b, where m and b are real numbers and m and f of x are both not equal to 0. So dapat ang slope and y-intercept are not equal to 0. That's linear function. And the third is quadratic function. Quadratic function is any equation of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and it should not be equal to 0. So a quadratic function is any equation of this form. Ax squared plus bx plus c. Like example, f of x equals x squared plus 2x plus 1. That's an example of quadratic function. Now, what's the difference of linear and quadratic function? If we will say linear, the highest exponent of the variable x is 1, while quadratic function, the highest exponent of the variable x is 2. So you have to take note of that. That is the difference of the linear and the quadratic function. Again, linear function is the highest exponent of the variable x is 1, while the quadratic function, the highest exponent of the variable x is 2. Now we go to asymptote. Now what is an asymptote? Asymptote is a line or a curve that the graph of a function gets close to but does not touch. So we have here lines asymptote. We have the vertical asymptote, which is the y-axis, and the horizontal asymptote, the x-axis. Did you remember the x and y-axis, the coordinate plane, the vertical axis, and the y-axis? So we have to take note of this vertical asymptote and the horizontal asymptote. And we can also name that two lines the Cartesian plane, but we are using in graphing. Now, how to find the intercepts of rational function? Intercepts are x or y coordinates of the points at which a graph crosses the x-axis or y-axis respectively. So we have two intercepts here, the y-intercept and the x-intercept. So y-intercept is the y-coordinate of the point where the graph crosses the y-axis, while the x-intercept is the x-coordinate of the point where the graph crosses the x-axis. You have to take note that not all rational functions have both x and y intercepts. If the rational function f has no real solution, then it does not have intercepts. So we have rule here. Number one, to find the y-intercept, substitute 0 for x and solve for y, or f of x. So if you want to find the y-intercept, just substitute or replace 0 for x and you solve for y. And to find the x-intercept, you substitute 0 for y and solve for x. So it's just vice versa. If mangita tag y-intercept, atong pulihan og 0 ang x, and we need to solve for y. And if we are going to find the x-intercept, ato akong pulihan og 0 ang y, and we need to solve for x. Okay, we have 3 examples here. Find the intercepts of the following rational functions. We have a, f of x equals x plus 8 all over x minus 2. Letter b, f of x is equal to x squared minus 5x plus 6 all over x squared minus 2x plus 3. And letter c, f of x is equal to x squared plus 9 all over x squared minus 3. So we need to find the intercepts of the following. Okay. For y-intercept, we have to replace x for 0, or we need to substitute 0 for x. So f of 0 equals 0 plus 8 all over 0 minus 2. 0 plus 8 is 8 over 0 minus 2 is negative 2. And we simplify 8 divided by negative 2. That is negative 4. Y-intercept is negative 4. And for x-intercept, we need to make the y is 0. So we have 0 equals x plus 8 all over x minus 2. So we have 0 equals x plus 8. And we have y, it becomes negative 8 because we need to multiply both sides by x minus 2 because the denominator here is x minus 2. So x minus 2 times 0 is 0, and x plus 8 over x minus 2 is x plus 8. We'll cancel the x plus 2 that we have multiplied at the right side because we have denominator x minus 2. And why it becomes negative 8? Because we need to simplify. So we have to subtract 8 both sides. So 0 minus 8 is negative 8, and x plus 8 minus 8 is x na lang. Kaya 8 minus 8 is 0. Therefore, the x-intercept is negative 8. Here in letter B, for y-intercept, we have f of 0 equals, we have to raise x with 0, so 0 squared minus 5 times 0 plus 6 all over 0 squared minus 2 times 0 plus 3. So we substitute 0 for x because we need to find the y-intercept. And then we need to simplify. 0 squared is 0, minus 5 times 0 is 0, so we have 6 na lang. And 0 squared is 0, minus 2 times 0 is also 0, and plus 3. So we have 6 divided by 3 is 2. Therefore, the y-intercept is 2. And if we're going to solve the x-intercept, so we have to substitute 0 for y or f of x. So we have here 0 equals x squared minus 5x plus 6, because we multiply both sides by x squared minus 2x plus 3. Since diba the given here a while ago, this number, okay, this number, letter B, f of x is equal to x squared minus 5x plus 6 all over x squared minus 2x plus 3. So here we will substitute 0 for y, and then we need to simplify. So we need to replace here the original equation, which is this one. So we multiply both sides by x squared minus 2x plus 3, because that's the denominator of the equation. So we have here okay, so we have 0 times x squared minus 2x plus 3 is 0. So we have 0 here at the left side, and here at the right side of the equation, we also multiply x squared minus 2x plus 3. And we can apply cancellation, and the remaining is x squared minus 5x plus 6. How to solve for the x? We need to factor this x squared minus 5x plus 6. So the factor x squared, x and x, and the factor of positive 6 are negative 2 and negative 3. It should be negative 2 and negative 3 because the middle term is negative 5x. We will not use positive 2 and 3 here because the middle term of this trinomial is minus 5x. So we need to use the factor of positive 6, the two negative numbers, because the product of two negative numbers are positive. Okay, we have here the factor x minus 2 times x minus 3. And we need to solve what is the value of x. So since we have two factors here, solve for x. So x minus 2 is equal to 0, and x minus 3 is equal to 0 also. And to solve for x, we will add to both sides. So x minus 2 plus 2 is x, and 0 plus 2 is 2. And x minus 3 is equal to 0, so we need to add also 3 both sides. So x minus 3 plus 3 is equal to 0 plus 3. So we have x equals 3. Now we have two x-intercepts here in example 2. The x-intercepts are 2 and 3. Okay, next is this letter C. So we need to solve for y-intercept also. You substitute 0 for x. So f of 0 equals 0 squared plus 9 all over 0 squared minus 3. And we need to simplify. 0 squared is 0, plus 9 is 9, and 0 squared is 0 also, minus 3 is negative 3. And 9 divided by negative 3 is negative 3. Therefore, the y-intercept is negative 3. Now we need to solve for x-intercept. We substitute 0 for y or f of x. So we have here, we multiply both sides by x squared minus 3 because that's the denominator at the right side. So x squared minus 3 times 0 is 0. And here is, we need to cancel out x squared minus 3. And we have denominator x squared minus 3 also. So the remaining is x squared plus 9. So just take note if there is a fraction, to simplify, we need to multiply both sides of the equation by the denominator of the rational expression that is at the right side of the equation. So we have here 0 equals x squared plus 9 and negative 9 equals x squared. So what shall you do? How to find the value of x there? Since that is x squared and that is a quadratic equation, and to find the value of x of the quadratic equation is we need to extract the square root of both sides. But negative 9 has no real square root. Diba? Can you get the square root of a negative number? No, there is no real solution for x squared plus 9 is equal to 0. Hence, there is no x-intercept for that given rational equation. Okay. The zeros of rational function. In the fraction n over d, d must not be equal to 0 since division by 0 is undefined. And in general, when dealing with rational functions, whatever value of x that will make the numerator 0 without simultaneously making the denominator equal to 0 will be a 0 of the said rational function. 0 means root or solution. If we will say the zeros of rational functions, meaning the roots or the solutions of rational functions. Okay, we have also guidelines here in graphing rational functions. 1, factor the numerator and denominator. Number 2, find the intercepts, x-intercepts, zeros of the numerator and y-intercepts. We have the f of 0. And the 3, find the vertical asymptotes. Determine the zeros of the denominator. And then find the horizontal or oblique slant asymptotes. You have to plot points to the left, to the right, and between the vertical asymptotes. And you see if y to positive or negative in each side of each vertical asymptote. And you sketch the graph, use the plot points and the asymptotes. Plot as many additional points needed to fill in the rest of the graph of the function. Okay. For our IFL, we have like rational functions. We also have curves in our lives. And even if we've encountered lots of problems and trials in our way, remember that there is God who keep watch over to remind us with a straight line, which is the path of righteousness. Despite of the X and Y, or the positive and negative sides that we have in our life, we must instill in our mind to always trust ourselves to God and to choose the things that's best for us. For God has a better plan for all of us. That's all for today. May you have learned a lot from our topic today.